Hello everyone, I'm Paul and today we're solving problem 498, diagonal traverse. This is medium, and here I will show you what I think is the most intuitive solution, so let's start. Our job is simple. We are given a matrix such as this one, and we need to return an array of the elements in this matrix sorted in diagonal order. So for example, if we are given this, we return this. And here the order is the following. First we have 1, then 2, 4, then 7, 5, 3, then 6, 8, then 9. So my first intuition here is we can store every diagonal into some data structure. And let's say this is diagonal 0, this is 1, this is 2, this is -1, and this is -2. And we need to store this in the form of key value pairs. And this is exactly a map. So we'll have a map with all of these keys. 2, 1, 0, -1, and -2. Now the question is, let's say we are standing here. How do we know that this cell belongs to this diagonal? And this is the key for this problem. And here we can use sort of like a small formula. If we were trying to get this diagonal instead, we would do column minus row. Right here we are at column 1, row 2. So this would be 1 minus 2. The result for this is -1, meaning this diagonal is -1. The thing is, we're trying to get the opposite diagonal. We want to get this one. And we can do something very similar. We can do m minus 1 minus this. Here m is 3, -1 minus the current column is 1, minus the current row is 2. And the result for this is 3 minus 1, 2, minus 1, 1, minus 2 is -1. So here, this value belongs to the diagonal -1. Now we can add this to the map. We go to the key -1, and this will have an array, and here we would add 8. So we can do exactly the same for every value in this grid. Let's go from the start. Let's say we are here. m-1 is 3 minus 1 minus the current column is 0, the current row is 0. So this is diagonal number 2. Here we have number 2. So we need to add in the map at 2. This will be an empty array initially, and the first value here is 1. And we are doing exactly the same for every cell. Next we are here. So we do 3 minus 1 minus the current column, 1 minus 0. And this is 1, meaning this belongs to diagonal number 1. So we go to the map at 1, we add the current value. Next we are here, so we do 3 minus 1 minus the current column, which is 2, minus the current row, which is 0. And the result for this is 0, which is the current diagonal, so we put this in map at 0 here. And now I think you get the idea, so let me fill this map. So now we can get the result, and for this we'll iterate this map, and we will have a variable, we'll call this current. This is initially 1. And when current is 1, this means we are iterating the current diagonal in this direction. If current is 0, we are iterating the current diagonal in this direction. Okay? So first current is 1, and we are iterating this element first. So we have this array. And this means we need to add this to the result in this direction. And in case you didn't realize, here we have everything in reverse order. For example, here we have 3, 5, 7, and here we have 3, 5, 7. So every array here is already reversed. So if current is 1, we need to reverse the current array. So given that here we have only 1, we add this to the result. Now here we have 1. And every time we want to change current. If this is 1, the next time this will be 0. And the next time this will be 1, and so on. Now we are here, we have this array, and this is 0, meaning we are iterating this diagonal in this direction. This means we need to keep this array as it is, and we add the values here to the result. So now we have 1, 2, and 4 here, and current is 1 again. Now we are here, meaning we are iterating this diagonal in this direction, and these are the values for the diagonal, so we need to reverse this and add every value to the result. And current is 0 again. Next we are here, so we add this as it is to the result. Now we have 6 and 8 here, and this is 1 again. Finally we are here, given that this is 1, we need to reverse this, and we only have one value here, so we add a 9 to the result. And finally we can return this array. So this is it for the approach here. Time and space complexity will be big O of n times m. So now let's go with the code, and hopefully you will get the idea. N is the length of matrix, m is the length of matrix at 0. Our dictionary is a default dictionary with a default value of an empty list for every key, so here we use the word list. And now we can iterate the initial matrix, so for I in range n, for j in range m, and d at the current diagonal, meaning m minus 1 minus j minus I, dot append the current value, meaning matrix I j. So now we have every diagonal in our map. The result is initially an empty array. Current is initially 1. Remember, we are using 1 for the initial direction. And now for every key in the map, if current is 1, we need to add to the result d at the current key, and we need to reverse this. In Python we can reverse an array like this, and remember, this is an array and this is another array, and in Python we can concatenate arrays with a plus. Else, meaning if current is 0, we add to the result d at the current key as it is. And every time we need to update current. If it's 1, we want this to be 0 for the next time. And if it's currently a 0, we want this to be a 1. So here we can use bitwise XOR equal 1. And finally we can return result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.